active failover. Active failover is nothing but the active standby failover in a multiple context environment. In other words, active failover is nothing but the active standby failover into the multiple context environment. So first of all, let's get familiarized with the topology. R6, the IP address is 10.1.1.6. Let's go to R6, FA0/0, so IP interface brief, FA0/0 10.1.1.6. Okay. So IP route, I have given the route for 20 network, send it to 10.1.1.10. I am planning that in context A, inside interface would be having the 10.1.1.10. I did not create anything, I am just planning. I have planned and that's what I have assigned to the router side. Okay, minimize it. Let's check R7. The IP address FA0/0 is 192.168.1.7 according to our context B configuration. This side it would be 192.168.1.7. ASA side context B inside interface will be 192.168.1.10 and gateway to the 20 network. Again I have given 192.168.1.10 as a static IP route. Alright, that's what you require at the router side. At another router R8, R8, see the IP addressing 20.1.1.8 according to our according to our topology. We have taken 20 network. Route also I have specified, but here you will see a little bit different static routes into it. If this guy is having any traffic towards 10.1.1.0, he will send the traffic towards the IP address 20.1.1.10. If he is having any IP traffic towards 192.168.1.0, then he will send the packet to the 20.1.1.11. I am sharing the interface E0. I am planning to share the interface E0 in both the context. Okay. Before we move ahead, let's do the VLAN configuration on a switch. So these two are the switch. Let's go to switch 2 first. How do you create a VLAN over here is VLAN database first and the privilege mode. Here you create the VLAN ID. Let's say we have plan 20, then exit, and it will be VLAN will be created. That's how you create the VLAN. In normal switches, you just type interface VLAN number or maybe just VLAN number on the configuration mode. It will create it, but in GNS it will not be created that way. Yeah, VLAN database. So here, if you see our topology, FA1/10 and FA1/8, both are connecting firewall and router. So we'll put both 8 and 10 into the VLAN 20, same VLAN. So interface FA1/10, no shutdown, switch port mode access, switch port access VLAN 20. Interface FA1/8, do the same thing. No shutdown, interface FA1/10, no shutdown. So interface status 8 and 10 into the VLAN, same VLAN. Okay, save this configuration. Go to switch 1. In switch 1, port number 6 and port number 10 both must be into the same VLAN. VLAN should be 10. Port number 7 and port number 11 must be into the same VLAN. VLAN number 192. Okay, make sure that first you create the VLANs and then only you start assigning the VLAN number to the interfaces. So VLAN database, VLAN 10, VLAN 192, exit. So VLAN brief, so VLAN switch will show you the number of VLANs. It's like show VLAN brief in the real switches. Here you have to execute the show VLAN hyphen switch. Now go to the interface 1/6, no shutdown, switch port mode access, switch port access, VLAN 10, interface FA1/10, no shutdown, switch port mode access, switch port access, VLAN 10. Same you have to perform for the 7 and 11. Interface appears 1/11. No shutdown. Switch port mode access. Switch port access. VLAN 192. Let's check it. 10, 11, 10 and 192. 6, 7, 10 and 192. So in other words, we can say that 6 and 10 are directly connected. 7 and 11 are directly connected, and that's what we require over here. Okay. Now, except the firewall, everything is set up perfectly. Okay. So let's save this configuration on switch 2 as well, and now go to the firewall. First of all, check the mode. It's into the multiple mode. Okay. So context, we don't have any context. So first step over here is you enable the shutdown. Enable the interfaces. Why am I enabling 4 interfaces? Because I have a specific requirement. E0 is already used in our topology, E1 is already used in our topology, E3 also is being used in our topology, E2 is not being used, but I will utilize it for the failover link. Alright, so just now I have enabled those interfaces, and that can be again verified by using the command show interface IP brief. All 4 interfaces are up. Now let's create the context. Before creating any context, any non-admin context, you have to have the context admin created. So if you try to create context, it will say that you had supposed to create the admin context first, or in other words, you have to have, or you must have, one admin context before creating any non-admin context. So how to create it? Admin context, admin, then you create context, admin, config URL, admin.cfg. Now you create the context, context a, config URL, context a.cfg, allocate interface. This is context A. So E1, I'll write it as a inside. So I don't want to see E1 in my context A when I go into the context. Okay. Allocate interface, E0 is outside. See the topology, E0, E1 here, context A, config URL is given. Now for context B, E3 and E0. Okay. Go to the AS again, exit context, context B, config URL, context b.cfg, allocate interface, E3 is going to work as a inside, allocate interface, E0 is going to work as a outside. Make sure that you execute the command make address auto. Why? Because E0 you are sharing in both. Alright. Now you have created the context. Save this configuration, go to that context, change to context A. Here interface inside, no shutdown was already given, so name if inside, IP address 10.1.1.10. We still are not talking anything about the failover. We are just making our topology working fine. Once we have the topology, then we will inject one more firewall into it, and then we will see active. It's not a big of explanation, very easy. Let's say 10.1.1. I hope this is R6. So the IP address of R6 is 10.1.1.6. At this point we should be able to ping our directly connected R6. So switch is configured perfectly right, and we have the reachability with R6. In the similar way, let's go to interface outside, IP address 20.1.1.10, name is outside, and let's check that do we have the reachability with 20.1.1.8. that is our R8, ping 20.1.1.8. we do have the reachability, so this context is working fine. Okay. Additionally, let's create the access list as well. inbound permit ICMP any. Let me squeeze this window a bit. Yeah, any access group inbound inside interface, inbound interface outside. Save this configuration. Go to the context context b. Context 1 is initialized really well. In other words, one virtual firewall is initialized. Now we are into the second virtual firewall. Again, interface inside IP address. What should be the IP address? 192.168.1.10, right? Name if inside, interface outside, IP address 20.1.1.11. Name if outside. Once we are done with that, we will check first the directly connected interfaces. Ping 192.168.1.7 and ping 20.1.1.8. Perfectly fine. Okay. Access list inbound permit ICMP any. Access group inbound in outside. Now routing is already been resolved. So let's see. From R6 you ping 20.1.1.8. Working fine. Alright. Let's go to R7. Ping 20.1.1.8. Both the contexts are working fine. Alright. So that is multiple contexts. As of now we had seen the multiple contexts only. Nothing else. There is nothing related to the failover. Now let me save this configuration. All the configuration actually it is already saved. Let me go to the firewall. Change to system, write memory all. If you want to save all the context, you just write the execute the command write memory all, and it will save all the context configuration into the respective files. Now let's introduce this backup device. Now this backup device is into the topology. Okay. First of all, let's start this device and see that whether he is operating into the right mode or not. If this device is not operating into the multiple context, no point of having the connectivity or no point of creating the connectivity. First of all, our requirement is what? We have to have that device to be operated into the multiple context. So we'll see it and then we'll create those connectivity. Okay. So mode, it is into the multiple mode. So context, the context admin is created, right? I mean, when you change the mode, admin context gets created by default. I am doing clear configure all. So interface IP brief. I don't have any other thing except no shutdown of interface IP brief. Okay, that's all you require at the standby device. So you minimize it and let's create the connectivity. Select manual. E1 should be connected to switch 1, right? So E1 connected to, let's say I am planning to connect it to 12 and 13. So 12 will be E1. E3 should be connected to the 13. Similar way this side, E0, let's say I am planning to connect it to 12. Okay. Before doing any other configuration, make sure that first you are configuring this port into the same as, in other words, FA1/12 should be same as FA0/12. FA1/10. What I mean to say is, so run interface FA1/10. This configuration must be there into the 12. It should be to the 12, right? So let's go to the interface FA1/12. We have connected 12 and 13, right? Alternatively, you can again click on this one, it will come up, but I don't want to overwrite all this. So just hover over this mouse and you will see that E1 is connected to FA1/12. So FA1/12 on switch 1, we are into the FA1/12. Now shut down, switch port mode, access, switch port access, VLAN 10. Interface FA1/13 should be which VLAN? 192. Done. Minimizing. Switch 1 is configured correctly. Now let's go to the switch 2. Which mode? Which port? Port number 12 should be into the VLAN 20. Okay. Port number 12. Interface FA1/12. Now shut down. Switch port mode access. Switch port access VLAN 20. So interface status will show you that these three are into the same VLAN. Save it. Okay. So you have replicated connectivity as active. One more thing, one more connectivity you require, and that is failover link. Okay. Alternatively, you can have that failover link via switch. In most of the practical scenarios, you will see it via switch. Okay. But we will directly connect it. We will not go again via switch. Again, if you are connecting via switch these two devices, firewall 1 and firewall 2, you are connecting via switch. Then you have to have those two ports into the same VLAN. But we will not do that way, but we will directly connect with the directly connected. Okay. And here failover link subnet will take, here only I am writing failover link name equal to F over IP. I am going to take 100.1.1.0/24 and it's E2. Okay. So this kind of notation will help you. This kind of notation will help you in understanding the topology in better way and where the traffic is flowing in all other stuffs. Okay. Now let's go to the active device. In other words, primary device. This was our primary device, right? Yes. So context. We have three contexts. Whereas this guy, newly introduced guy, or backup firewall, he does not have any context. Okay. Let's change it the host name as backup, so we'll be able to identify before we start the failover. How do you configure the failover over here? Let's say, okay, failover LAN unit primary, failover interface, failover LAN interface, F over, we decided that we are going to take logical name as F over and the physical interface is E2. Then failover interface IP, we are going to take 100.1.1.10 255.
This shouldn't be defined under context.
No, that's what I was going to. F over 100.1.1.10 255.255.0 standby 100.1.1.11. Failover configuration should be into the system context. It should not be into the context, under the context. I'll tell that what what will make the difference between the context, or I mean who will make a decision for which context you should be active and which context should be, that I will tell. Okay, so we have specified what? So run failover, only 3 commands. One more command is still missing, and that is failover len enable. Okay, if you are still with me, then you probably might have noticed that for rest of the context A and context B, whatever the IP addresses we have assigned, there we did not specify the standby IP address. And for failover to be happen, you have to have the standby IP address, right? So let's go to the context. So interface IP brief, we have to change this configuration with standby IP address. Okay, so interface inside IP address 10.1.1.10, standby 10.1.1.20. 11, we will take 11. It will take some time to get that IP address assigned. Interface outside IP address 20.1.1.10, standby 20.1.1.11. Similar thing you need to do at the context B side as well. I mean in the context B.
You will not define this as active or standby. This context A as active or
No, that I will tell. We are not doing anything related to the failover as of now. As of now, we are just meeting up the prerequisite of failover, because standby and active has to be assigned. That we did not assign when we were configuring the multiple context. That's why. Change to context context B. So interface IP brief. Here it is the IP address we typed wrong actually. Here we planned out 20.1.1.20, not 20.1.1.11. Okay, so we'll change that IP address as well. Go to this guy, interface inside, IP address 192.168.1.10, and standby is 192.168.1.11. For outside, the IP address is 20.1.1.20, standby is 20.1.1.11 or 21. We'll take it 21, 20 and 21. Interface outside, IP address 20.1.1.20, standby 20.1.1.21. Let it initialize these interfaces. Okay, done. So run access list. We have this, everything is configured. Now let's save it. Let's come out from this for context configuration. Now we are into the system configuration, right? Here you have to say that failover first command group, failover group, and maximum group you can create it only 2. Okay, so failover group 1. For group 1, what would you like to be, primary or secondary? I'll tell that how exactly it is going to be reflected with the context. So here I am saying that I want to be a primary. Group 1 I am primary, I mean group 1 is a primary. Okay, and then I am saying that you do the preemption. Okay, for failover group 2 he is a secondary, group 2 is a secondary, he also wants to do the preemption. Now I have 2 failover groups, group 1 and group 2. Okay, now how do I make the distinctions, or how will I say that this context you become active, this context you become the standby? Okay, how? Context context A, and here I will say that join failover group 1. Context B, and I'll say that join failover group 2. So run failover, so run context. Let me maximize the screen. See here, I created two groups, right? Group 1 and group 2. Whenever the group is primary, it is a default, so you will not see this under the group 1 in running configuration. It's a primary. For group 2, it is a secondary, right? Now we said that context A, you become a member of group 1. So this firewall is going to become active for context A. Okay. This firewall for this context is going to become a group 2 member, means secondary. If I am allocating or I am saying that I am a secondary, it means that I am giving a chance to the other guy to become a active, right? I am voluntarily saying that I want to become a secondary guy. So if I am saying secondary, means alternatively I am saying that other guy is active. Okay. So that's all the configuration you require. At active side, go to the failover device, I mean standby device. Let's check it. Do we have any failover configuration? No. So what are the configuration you have to configure? Failover, lane, unit, secondary. This is like unit wise. I mean box wise secondary and primary something else. Context wise primary and secondary something else. If box is not working, both the context are active. Okay. Failover, lane, interface, F over E2, failover interface IP, F over 100.1.1.10, standby IP address is 100.1.1.11. Failover lane, enable, save this configuration, go to your first primary. And here one more thing I forgot to tell you, and that is, okay, we'll just remind me that failover, stateful failover. Just remind me right after this practical. I mean right after we see the active, just remind me the stateful failover. Okay. So there is one more command which will help you the stateful failover to see. Let's enable the failover process. Failover. I think again it will not work. We have to restart the complete topology. It's not working. Obviously it's not working, otherwise it will not take this much time. Yeah, it's not working obviously. Let's disable it and we'll restart the complete topology. In real rec you will not see, definitely you will not see anything like this one. You don't have to restart the boxes. Let me restart it and I will come back. Let's enable the failover now. I again restarted those two firewalls. Failover. Let's see whether it's working or not. Yeah, I think it will work now. See, on the standby device, if you still notice it, it says that detected in active mode, right? Right after this one, as of now, you are saying that group 2, no response from a mate. Group 2 means at primary device, you said that I am not going to be active. Group 2. Group 1, I am active. So I will force another guy to be standby. Then what configuration it is copied, I think. Group 1, so run context, we said group 1, group 2, okay. Let's check it. So failover. This device is active, other device is standby. See, group 1 is active, for group 2 is standby. Okay. How do you check specifically? Change to context context A. So failover. This is context A. This context is active. Okay. Let's go to a context B. So failover. This context is standby. If you go to the standby device, this is standby device. Just now the whole copy has happened from the active to standby. Okay. Change to context context B, and you will see that it is a active guy. So every traffic will be passing through this box for context B. In other words, from our topology, from R7 to R8 will be passing through this guy, for R6 to R8 will be passing through this guy. One more thing, you probably might have noticed it, that we did not really configure anything related to the context on standby. Only no shutdown, failover, rest of every configuration has been replicated from where? Primary to the secondary. Okay. Now let's see. I am closing down these two consoles so we can see it actually. I don't have firewall console open as of now. Okay. As I said that R7 to R8 is passing through FA1, right? Let's say R7, go to R7. Okay. Ping 20.1.1.8. Does it have a route? Yeah, previously we checked, we had a route, right? Yeah, the reason is simple. 192 it is okay. You go to R8, the problem is with the R8. I'll tell what is the problem. So IP route, previously we said that you send it to the 20.1.1.11, but we changed the IP address to 20.1.1.20, right? IP route 192.168.1.0. Remove it and again inject it with the right IP address. Now you ping 192.168.1.7, right? Now what is the proof that it is passing through that device or not? Let me go to this firewall console, context B. I am into the context B, right? I have a access list and which is allowing you to pass the traffic, right? I have applied it under this access list to the outside interface. Let me remove this access group. No, remove it. I am into that physical box. I have removed the access list, so nobody should be able to send any traffic from 0 security level interface to the 100. Let me go back again to the R8. From here, just now I have tested, right? And you will see logging console 7, logging enable, and you will see that it has been denied over here only. Let's see again. Deny inbound ICMP traffic. Alright. Now this one is tested, right? Now let's suppose, did I break it? Okay. Now let's suppose, let's test this connection R6 to R8. I am going to R8 and I am configuring telnet for it. Just telnet I am configuring, or I am enabling the telnet, enable password. As you know that from higher level security to the lower level security, traffic goes without a problem, and since global policy is inspecting many traffic, specifically UDP and TCP, so if I telnet from R6 to R8, R6 to R8, I will be able to telnet it, right? Okay, let's go to R6, telnet 20.1.1.8, and I am into the R8. So traffic passed through which context? Context A. Which firewall? Firewall is this one, right? Let's right click it, go to the console. You are into the context B, so wrong context, change it to the context context A, and here so connection will give you the information about who has made the connection through you, right? So the initiator is this guy, because the crazy source port, destination is this guy. Now this failover, what just now we saw, is stateless failover, means from active context to the standby or active device to the standby device, the state information or state table entries will not be transferred. So let's suppose I have a telnet open, right? R6, I have a telnet open connection. Now this guy goes down, he will take a role of active, but he will not be having the connection table entry. So to make that stateful failover, we have to again define the failover, stateful failover link. Let me show you the proof. Let's go to this guy for standby for no logging enable, no logging consoles. Okay, change to context context A, and show connection. I don't have it any, but at active device I have one. So if you want to give user uninterrupted failover redundancy or ASA redundancy, then you must have the failover link as well. Stateful failover link as well. So there are two type of link into the failover of ASA. One is failover link that we saw already. E2 is our failover link. Another link is stateful link. You can have your data link to become a stateful link or your failover link to become a stateful link. So only one command you require at the active device, primary device, not active device, primary device, global primary device, not context wise primary device. Okay, so this was which console is this one? I think this one, right? Yeah, this one is a primary device, right? Because context A is active in primary device and this is the context A. So here you have to execute the command failover link E2, F over and E2. That's all you require. This one command says that you are specifying the stateful link and only onto the primary device, not onto the secondary device. This will automatically be discovered by the standby. He will learn from the active device only. So let's go to the yes. For that again you have to restart the failover. Okay, let's suppose no failover. I am disabling the failover. He will say that if I am disabling the failover, this device will become the standby or will remain the standby only, but no problem. I am also saying that no failover here. From R6 I will say that you exit out. I am done with the telnet. Let's test it again. Okay, command is not replicated to standby unit, no problem. So run failover, we have no failover on both the device. Again let's enable the failover, and make sure that whenever you are enabling the failover, you should type that failover command first onto the primary device. Otherwise the replication will be other way around. Your complete configuration will be erased with the blank configuration. If standby unit had a chance to become a primary, to active, let's suppose you enable the failover at the standby unit, 45 seconds is gone, and then you are enabling this active device, primary device. So he was already active and preempt is not there. He has to forcibly consider himself as a standby, and the command replication Rule is saying that always active to standby. So active has 0 configuration. This guy doesn't matter how much configuration, he will be replicated with the 0. And I have done many times that mistake. You should not do it. Specifically into the exam. Change to context B. So failover is active. Change to context. So failover is standby. So this is our standby unit, right? I mean newly introduced device. This one is your actual primary device. Or you can say that prompt context state, this is active device. Okay, you go to the standby, change to system is standby, system level is standby, change to context context B, context wise is active. So that command will help you in identifying that in which device you are into, because host name is also replicated, so very hard to track it down. Okay, now let's go to R6 again and again perform the same test what you perform for the telnet. Go to your active device, change to context, so connection, right? Go to your standby device, change to context context A. Do you see the connection table is also translated? Now what happens if this device goes down? So he will become the active for both. So this R6 will not have to re-establish the telnet connection. He will not even feel that there is something happen in the network. Okay, how to make this failover to happen? Go to switch FA, let's say switch 1, config T, interface FA1/10, shut down and wait for 45 seconds. You can actually minimize that time with the command called failover poll time. Okay, in JNS sometime it doesn't work, but most of the time it works. Sometime, rare case it doesn't work, most of time it works. This was your active device, right? So failover will show you that interface is failed, right? So once the interface is failed, he has to again start the election. He says that I am not having this much capability as you are having, so I want to give up my active role. If you have more resource available, you take it, and you will see this guy will become the standby. This guy became the standby. Now my telnet session was still up, I think. Yeah, telnet session was still up, right? I did not exit out. Let's press enter. I am still ready to go. Did I feel that failover has happened? No, right? Now if you go to the standby device, sorry, this was your standby device, right? Previously context B it was active, context A it was standby, right? Now press enter and you will see this is active. Why? Because context A, the firewall which was active for context A is failed. So now this device is active for both the context. Sorry, here you can check it. Group 1 is active, group 2 is also active. Okay, he became active for both the device, I mean both the context. So that is active, yeah.
What about the packets that's work already in the flow? I mean, still there will be.
No, you can minimize.
No.
No. You can minimize. That's what I said. That you can minimize.
Minimum to 1 second. We can minimize it. Right.
Millisecond, not 1 second. Millisecond. Hold time is the command. Hold time. See here. Hold time interval default is 15 seconds, right? You can say that millisecond. And you specify. In 200 millisecond or 100 millisecond, you will not even.
200 milliseconds will not whatever packet will be
Yes.
gone, it will be dropped.
Not drop. 200 millisecond means how many packet will you be having in 200 millisecond?
Oh,
Not
one packet.
second.
See, the packet flow is so fast. I mean, in one second,
Probably let's say, we'll say that 0.001 percentage of 100 Mbps.
yeah.
Probably. 200
Maybe
millisecond means
not.
nothing. So yeah, packet loss, I mean 0% packet loss is not there. You have packet loss, but very minimum. Very minimum. Alright, so that is active failover. I will stop here now.